Microscopy. The microscope is an optical instrument that uses a lens, or oftentimes multiple lenses, to magnify and resolve fine elements of an object. The role of any kind of a microscope is from something as simple as a magnifying glass all the way up to a scanning electron microscope is going to simply take something that's small, employ some distortion of light principles, and then make it appear bigger to you. Microscopes can do this in varying degrees of detail. Sometimes microscopes can have a very fine resolution. Sometimes it can be very coarse resolution, but you can see the overall shape be magnified. It can vary. Each microscope has a discrete role. Just because one microscope is good or something needs to be magnified doesn't mean that you can use any old microscope. Everything has its place, and everything has its pros and cons. We'll talk about the pros and cons of each microscope in future slides. A common mistake that students make is to assume that the more magnification power something has, the better it is. More magnification does not automatically equal better. It's not a better microscope. It simply is capable of zooming in substantially more. For some things, you might just want to be able to see all the things that you can see with your naked eye, but bigger and clearer. For that, a low magnification microscope is going to be useful. Something like a magnifying glass would be super useful for that purpose. If you want to look at the electron or the atoms that make up an object, a scanning electron microscope is going to be beneficial. But if you wanted to see just some of the surface details clearer, and you put it under a scanning electron microscope, you're going to lose all the detail that you need. It's going to be too far zoomed in, so to speak, and you'll lose all the context you were hoping for. So different microscopes can resolve things to a different degree and can magnify things to a different degree. Not more does not automatically equal better, and you'll need to use your discretion in determining what the best microscope is for a given job. The magnifying glass is the simplest and earliest magnification instrument. A major benefit is that it's handheld. You can carry this around on your person. Other benefits include that it's very inexpensive. When talking about any materials, a department has a finite budget. If you have an inexpensive and very useful instrument, that's a really valuable commodity to have. It requires little to no training. To use also. Some types of instrumentation require a fair bit of very specialized training, or at least you need to provide your technicians with a fair bit of education to understand the principles behind the instrument involved. A small child can figure out how to use an magnifying glass with little to no additional help. It's very, very intuitive. You don't need to train anybody on it. You just need to give it to somebody and have them play with it, and if they break it, who cares? It's cheap. Magnifying glass demonstrates how refraction can cause images to appear larger. Refraction is the bending of light. We're all familiar with the phenomenon of looking at a drinking glass. You have a spoon that's in that drinking glass, and it appears bent. Oops, I didn't do the actual spoon. That's supposed to be a spoon. Bear with me. And you can see how it looks broken or bent when you look through the water. When light enters the water of that glass, it slows down substantially. Water moves more easily through a low density medium such as air, and slower through a higher density medium such as water. When it slows down, it bends. It literally hits that surface of the object and then changes direction as it slows down and causes things to appear in a different place based on how much it had slowed down. You employ that same characteristic with a magnifying glass, where you have a glass that's something like this, light from an image comes at it, and when the light hits it, it bends and it spreads out too, and it makes that image bigger on the other side. We'll go into a little bit more detail about that in future slides. This demonstrates the creation of a virtual image. The next set of slides discuss the real versus a virtual image. The most commonly used microscopes in forensics include the compound microscope. This is one you've probably used in labs where you have slides and you look at it through one of these guys. You have the slide right here, and you can magnify things 4 times bigger, 40 times bigger, 100 times bigger, etc. This is what you'll use to look at stuff like hairs and cells, very, very, very small things like that. Stereoscopic microscope, also known as a dissecting microscope, forgive me if I just default to calling it a dissecting microscope going forward. I do tend to use that term more often since my background is in biology. But a stereoscopic microscope employs many of the same principles as a compound microscope, but it does not magnify nearly as much as a compound microscope. In addition, its light source illuminates the object that it's viewing differently from a compound microscope. So it's useful for a different, it's not just the lower resolution and therefore more useful in giving context, but you'll use it with certain different needs as well. A comparison microscope is basically just a side-by-side microscope. You look in, there's your eyeball. I never said this was an art class. You will look in the eyepiece. You will have 2 sets of magnifying glasses or lenses here. You'll have 2 stages, each with a similar thing on them. The images will travel up both to your eye, and you can see both of those objects side by side to compare them. Comparison microscope. A polarizing microscope employs different types of selecting for different types of wavelengths to determine the characteristics of something. This is useful in figuring out what certain kinds of objects are made of, particularly when there's metals involved somewhere, like for paint chips, for example. Scanning electron microscope is a very sophisticated piece of equipment that you'll find mostly in like very extremely high level laboratories, like the FBI has one, but your local PD probably doesn't. You find it at major research universities. This can illuminate the structure of objects down to the atomic level. It requires a huge amount of training to do, and is not the type of thing that your average technician has ever even seen. They're outrageously expensive pieces of equipment and very, very tricky to handle, but extremely useful at determining the nature of certain extremely small particles. And finally, oops, there's a typo. This should be microspectrophotometry. Microspectrophotometry. And what this will do is it'll help you determine what wavelengths of light are reflected off of something to an extremely high level of detail. You're not actually going to magnify the whole image so much as quantify what types of light waves are reflecting off of something to better characterize what it's made of.